The concept of ergodicity describes the idea that a dynamical system left to evolve for a sufficiently long period of time will eventually visit all parts of the space in which the system is found. This idea applies to random and stochastic processes. In an ergodic system or an ergodic process, there is no distinction between spatial and time averages. In other words, these two averages simply fuse to one unique probabilistic average. More of that in another video.
In physics, the concept of ergodicity is very much related to that of entropy. Entropy is the degree of disorderness of a system. To see this relation, let's recall the second law of thermodynamics, which basically states that the entropy of a system always increases. And I just point by the way that the universe is the largest possible system. So consider, for example, smoke placed inside a room. We observe that the smoke particles diffuse via Brownian motion, which is a random process, and after a certain time, the smoke particles will have gone through all the space of the room. They will have occupied all the space of the room. In other words, the entropy of the system has increased. Another way of seeing things is that the smoke particles will have occupied all possible configurations after a certain amount of time. And this is a clear example of an ergodic process. Mathematics has a quite different perspective on the notion of ergodicity. In maths, ergodicity states that if you measure all the possible outcomes of an experiment involving random variables, then the outcome you get enables you to build back the sample space of the system. In reduced terms, the sum of the probabilities of all subsets of a given set equals 1. A good example of this is in Bernoulli trials. If you flip a coin 100 times, you'll get on average the same result, probabilistically speaking, as if you had to flip 100 different coins simultaneously. The ergodic theorem has a wide range of applications, more particularly in statistical mechanics, in Riemannian geometry, in stochastic processes, in finance, and even in number theory. We can thank Ludwig Boltzmann for the substantial contributions he brought in order to shed more light on this concept. Let me know what you think of the concept of ergodicity in the comments below. Personally, I find it very interesting, and it just gives us another way of looking at reality, the common things we do in our daily life, and try to make sense of randomness. Mind liking, subscribing, and see you in the next video.